Hello and welcome to another episode of James and Chris Science Videos, where today we're going to be looking at limestone, which you'll find is a rock. It's a sedimentary rock, which means that it's made up of loads of sediments that settle over time, usually at the bottom of seas and things. It's quite cool. Inside you find lots and lots of dead seashells and coral, and it's a real good place to find fossils. Where I live at the moment in Dorset, we are surrounded in limestone, so quite often in the fields when they've been ploughed, you do find lots of different fossils. This here is one that we found in a field not too far from here. And you can see inside there's a lovely grey ammonite, which goes around here. And you can still see, even on the other bits, the different seashells and things that make up this rock. So over time, all of these things fall to the bottom of the sea, where they get compressed, contracted and squeezed over time. And as that squeezes, the rock forms together and solidifies into that limestone. So it's got a chemical name, and you need to know its chemical name to go with that. Its chemical name is calcium carbonate. So it is made up of three elements: calcium, carbon and oxygen. That 8 at the end signifying there's oxygen there. The chemical formula is CaCO3. So that's one atom of calcium, one atom of carbon and 3 atoms of oxygen. Now, it's really useful to know that formula, because when looking at the reactions later, it's going to be really key if you know what elements are there, because they're going to make up the products. So carrying on, there are several reactions that we need to know about that are quite useful, that produce certain different chemicals that we use in industry and so on. So the first reaction is this. This is thermal decomposition of calcium carbonate of limestone. Now, it's not a very exciting experiment, and I decided not to go into the lab to show it you because it's not very exciting. It's literally, you take a boiling tube, as you can see here, you put your calcium carbonate in and you heat it at the bottom, and after 5 minutes the calcium carbonate goes a little bit yellow. Now, it does produce a gas, and the gas comes out and will go through the delivery tube and would go into the lime water, and the lime water, as you know, is the test for carbon dioxide, and that lime water will turn a nice cloudy colour. So why do we bother doing this? Well, the main reason is that one of the products, calcium oxide, that's used to make cement. And so in terms of building and industry, thermal decomposition of calcium carbonate of limestone is really important, because it gives us that building block for the cement. It's also used for neutralization of acid, which we'll talk about a bit later, particularly when we're talking about acid rain and products with that. Now, I did want to at this point out there is another thermal decomposition reaction that the ISEB syllabus says you need to know, and that is the old copper sulfate. So the copper sulfate, those lovely blue crystals, if you heat them, they lose the water. They're hydrated to start with, which gives them that blue colour. So when you heat copper sulfate crystals, they actually turn white and you get steam coming off. It's good because that then forms for us a second reaction where if I put water back in, they turn blue. So going the reverse of this reaction is one of our tests for water. So I just thought I'd put that in there as it kind of fits in. That's the other main thermal decomposition reaction that comes through. Now, I should point out at this point that another little question that they quite often ask is about the safety of this experiment. So if I heat at the bottom the calcium carbonate, I expand the air inside that tube, and that'll force the carbon dioxide through the lime water, which is good. Now, if I then stop heating, what we find is the air inside that boiling tube cools, which will cause it to shrink, making a vacuum, and that will suck water back up the tube. And if the water goes back up the tube and it's still reasonably warm in there, water and reasonably warm glass can sometimes shatter. So that's quite a common question. They say, what is the importance of removing the tube from the lime water once you finish the experiment? And it's to stop that. It's called capillary reaction, where it gets sucked up and goes back into the calcium carbonate. So the next reaction that's quite important is reactions with acids, where it's used to neutralize acids and get rid of them when we don't want them. So here I've got one, it just says calcium carbonate plus hydrochloric acid, Now, we've done these acid reactions quite a lot, so just to remind you, to make a salt, you take the metal, calcium, and you take the non-metal part of the hydrochloric acid. Remembering that hydrogen's that funny kind of element that can behave like a metal or a non-metal in different things. So we're going to ignore the hydrogen for the moment. So we take the metal, the calcium, we add the chloric. Now that forms chloride. That's the naming of it, because remember, ide means is joined. So calcium chloride means calcium joined to chlorine. Now this is where I said it was important to remember the symbols for limestone, CaCO3. So if I did that, I get my calcium chloride, that's there, but I'm still left with one C and three O's, and the hydrogen from the acid. So my other two products are made up from those. CO2, that's one carbon, two oxygens, is my carbon dioxide, and that will leave me with two hydrogens and one oxygen, which makes my water. Now I've included a little kind of apparatus at the bottom. The apparatus, just to remind you again really of how we collect gases and how we can measure how much gas is produced. So very simple there, it's some marble chips at the bottom, that will fizz or effervesce, that'll force gas, gas will come out the top, and as it comes out the top it will go around and into usually an upside down measuring cylinder so that we can measure exactly how much it goes down. So the last thing that you might need to know and be asked about is common uses for limestone and some of the products. So I've already mentioned one already, which is the cement. The calcium oxide is used as a building, and it's one of the things that's used in that limestone. You can also buy direct lime and put that on the wall. So it's kind of like a product used that doesn't stop water going through. So it's quite useful for old buildings. And so they call that just lime. The other two uses that are quite common is neutralising the acids in lakes. So quite often to look after your fish, if you've got some prize stock, you might occasionally put lime into your lakes in order to neutralise them. It's used a lot in countries that have suffered from acid rain. So the Scandinavian countries, for example, Sweden, Norway, Finland, with their problems in the forestation where acid rain from Europe has caused severe deforestation and problems in lakes, they will import limestone and lime and spray that into their lakes to neutralise them. The last, and I know we've got quite a few farmers that come to school, is the liming of fields. And so quite often farmers will go around and they spread lime and limestone over their fields in order to get rid of the acidity in the soil. So if you wanted to grow a crop that needed pH 6.5 but your soil was pH 5, what you would then do is you then spray your field with the lime or limestone in order to try and neutralise it and move the pH towards where you want. I hope you found this interesting and useful. See you again. Thank you very much. Bye.